everyone, this is me once again, Teacher Christy from Davao City National High School. Today, let's talk about equations transformable into quadratic equations. Before we proceed to our lesson, let's recall how to find the solution of the following quadratic equation. Let's have this. X squared minus 4x plus 4 equals 0. In our previous lesson, we discussed the four methods of solving quadratic equation, and those are extracting square root, factoring, completing the square, and quadratic formula. And I'm going to use the quadratic formula, and this is our quadratic formula. Using quadratic formula, we must identify A, B, and C. Our A is 1, our B is -4, and our C is 4. Use all these values to substitute using quadratic formula. Please observe, our B is -4, our A is 1, and our C is 4. So negative times -4, we have +4, plus and minus -4 times -4, we have +16, -4 times 1 times 4, we have -16, all over 2 times 1 is equal to 2. 16 minus 16, we have 0, and square root of 0 is 0. So from here, x is equal to 4 plus or minus 0 over 2. We will separate these two signs. So we got 4 plus 0 over 2, and the other one, 4 minus 0 over 2. Simplify, we have 4 over 2. 4 divided by 2 is 2. And the solution of x squared minus 4x plus 4 equals 0 is 2. You are able to find the solution of the quadratic equation. Now, let's add and subtract fraction. Let's have this 1 over 3 plus 2 over 5. To add fractions, we must remember that the denominator or the denominators of the two fractions must be equal, but in this case, the denominators are not equal. So, let's find the LCM. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, so on and so forth. And the multiples of 5 are 5, 10, 15, 20, 25, 30, so on and so forth. For these two numbers, 3 and 5, the common multiples are 15 and 30. And the least common multiple of 3 and 5 is 15. And 15 is our new denominator. So 15 divided by 3 is 5, times 1 is 1, 5. 15 divided by 5 is 3, times 2 is 6. So simplify, 5 times 1 is 5, 3 times 2 is 6 over 15. 5 plus 1 or 5 plus 6 is equal to 11 over 15. Let's have this. 1 over 5 minus 2 over 5. Since these two fractions have similar denominators, we will just copy 5 and then subtract the numerators. 1 minus 2 is equal to -1, and the final answer is -1 over 5. Solving quadratic equations that are not written in standard form. So let's try this. Solve x times x minus 5 equals 36. This is a quadratic equation that is not written in standard form. To write the quadratic equation in standard form, simplify the expression x times x minus 5. So x times x is equal to x squared, and x times -5, we have -5x equals 36. Write the resulting quadratic equation in standard form. So it becomes like this: x squared minus 5x minus 36 equals 0. Use any of the four methods of solving quadratic equations in finding the solutions of the equation x squared minus 5x minus 36 equals 0. And I'm gonna use factoring. Try factoring. The factors of x squared minus 5x minus 36 equals 0 are x minus 9 times x plus 4 equals 0. Then apply zero product property. We have x minus 9 equals 0 and x plus 4 equals 0. So the final answer, the roots of x squared minus 5x minus 36 equals 0 are 9 and negative 4. Check whether the obtained values of x make the equation x times x minus 5 equals 36 true. Let's have this. Go back to the original equation, x times x minus 5 equals 36. Substitute 9 to x. So 9 minus 5 we have 4, and then 9 times 4 we have 36. So 36 is equal to 36. Check. And then do the same with negative 4. Negative 4 minus 5 we have negative 9, and negative 4 times negative 9 we have 36 equals 36. So check. The solutions of the equation x squared minus 5x minus 36 equals 0 are x is equal to 9 and x equals to negative 4. Okay, let's proceed to solving rational algebraic equations transformable into quadratic equations. Solve the rational algebraic equation 6 over x plus x minus 3 over 4 equals 2. The given rational algebraic expression or algebraic equation can be transformed into a quadratic equation. To solve the equation, there are following procedures to be followed. So just like adding or subtracting fractions, we must see to it that x and 4 or the denominators must be the same. But in this case, the denominators are not the same. So let's find the LCM, and the LCM is 4x. So we have to multiply both sides of the equation by the least common multiple, and that is 4x. And then 4x times 6, we have 24x over x, and then 4x times x minus 3 over 4 is equal to 2 times 4 is 8. So how do we get this answer? We just simply cancel x. 24 is left, and then cancel 4. What is left is x, and then x times x is equal to x squared. X times 3 is equal to negative 3x equals 8x. Write the resulting quadratic equation in standard form. So by transferring 8x to the left side, from positive 8x, it becomes negative 8x. And then combine like terms. So we got 24 plus x squared minus 11x. Rearrange. X squared minus 11x plus 24 equals 0. From here, we can use any four of the methods, but I'm gonna use factoring. Try factoring. The factors are x minus 3 times x minus 8 equals 0. Then apply zero product property. X minus 3 equals 0. X minus 8 equals 0. And then simplify. Our solutions are 3 and 8. Then let's check. Let's go back to the original equation. Observe, 6 over 3 plus 3 minus 3 over 4 is equal to 2. So 2 plus 0 over 4 is equal to 2. So 2 plus 0 is equal to 2, and then 2 is equal to 2. So check. Do the same on the right side. 6 divided by 8 plus 8 minus 3 over 4 equals 2. And then simplify these fractions. So by getting the factors 3 times 2 and 4 times 2. Cancel 2. What is left is 3 over 4 plus 5 over 4 equals 2. Then since the denominators are the same, just copy 4 and then add the numerators. 3 plus 5 over 4 equals 2. We got 8 over 4 is equal to 2, and then we got 2 equals 2. So our solutions are correct. Thank you.